Hi, everybody. How's the day?
We'll go live in just a second.
Okay.
Good afternoon, everyone. Thank you for joining us today at our virtual brown bag. We are having a women in engineering panel. We had a women engineering panel last semester that was very well received, so we decided to do it again, bring in more of our women faculty. Today's topic for the panel is work-life balance, but we're going to be broadly talking about a lot of different things on the panel. We do have already some folks watching with us, which is fantastic. So if you have questions as we go on, please be sure and put your questions into the chat, because if you put them into the chat, there's a Q&A space, then we'll be able to look at them and I'll be able to share them with our panelists as we go on. So we definitely look forward to having questions from our audience. So what I'm going to start off with first is introductions. So I'm going to have each of our faculty members introduce themselves. I'll throw my intro in at the end. And then we have some questions that we'll start with, and we'll make sure that you know a little bit about each faculty member. But again, please feel free to put your questions into the Q&A so that we can address those during this activity, because we would love it to be very interactive with you audience members. Okay, so let me start off. I'll go in the order they joined the program. So we're going to go with Hyejin first, and then Caroline, and then Sherri. So tell us who you are, tell us your department, your rank, and a little bit about your research that you do. So Hyejin, go ahead and start. And you're muted at the moment, so go ahead and unmute. There we go.
Thank you, Dr. Tiernan, for organizing this. My name is Haiying Huang. I'm a professor at Mechanical and Aerospace Engineering. I have been at UTA for about 15 years now. Prior to that, I worked in industry and then decided that was not for me and come back to academia. My research is on developing sensors, both for structures, basically trying to monitor airplanes, structures, and make sure that they don't break while we're using it, and also have some project that using sensor to help prosthetic users. So basically, my research area span both mechanical, aerospace, and bio.
Fantastic. Thank you so much. All right, and Dr. Kallie has joined us, so she'll be fourth in our order here. So Caroline, please introduce yourself.
Hi, I'm Carolyn Creachy. I am an assistant professor in industrial manufacturing systems engineering. I've been here at UTA for 4.5 years. Prior to that, I was faculty at Iowa State for a few years, and I did spend a little bit of time in industry before getting my PhD and joining academia. What can I say? Oh, my research area. So very broadly, my research generally focuses on supply chain management, logistics, so looking at distribution system design and management. More specifically, my research is focused on sustainability and regional food systems. So trying to improve the sustainability and the efficiency and the resilience of our food systems. And so a lot of work here in Texas and elsewhere throughout the U.S.
All right, thank you so much. And Sherri, please tell us about yourself.
Sure. So I'm Sherri Kermanshachi. Actually, I joined UTA 6 years ago, and time flies very quickly. And I got my PhD at Texas A&M University before joining here, so it's a long time. I am in Texas. I have 2 masters, one in civil engineering and one in MBA. And I think after the age of 7, I was in the school. Just my position changed from the student to the teacher. But I've been in the school forever. But I have experience in industry while I was doing PhD and also doing other degrees. And some of my research background is I work in the area of smart cities. I mainly work in 2 areas. One is on the autonomous vehicles. You might have seen the rapid vehicles that we have around the campus. So that's one of the projects I'm working on, integration of autonomous vehicles into transit services. We are hopefully going to the next phase, which would be very interesting. And the other area that I'm working in is in disaster recovery and resilience transportation infrastructure. So building back better after so many disasters that are happening currently.
All right, thank you so much. All right, Rosie's getting set up. She's shifting her camera around a little bit. So let me introduce myself while Rosie's getting herself situated. My name is Dr. Carter Tiernan. My home department is computer science engineering. I'm also assistant dean in the College of Engineering. I don't have a research program, although I do work with a number of faculty, and I do write grants primarily in engineering education and scholarships. For the college overall, I'm in charge of working with the scholarship programs. I work with student outreach. I assist with the recruiting. I work with student activities outside the classroom, so undergraduate research and other types of things like that. So I'm involved in lots of things that are outside the academic classroom focused part of being a student. So trying to support our students in engineering. I do teach a couple of classes. I teach in computer science, the intro to programming class, and I teach for the college, the intro to engineering for transfer students. So I've been doing those classes for a while. I've been at UTA full-time. This will be my 22nd year full-time, but if you actually count from when I was a student, because I did my PhD at UTA, I have been associated with UTA since 1988, and I started teaching classes as a grad student in 1990. My background before that, I worked for Texas Instruments. My background between 1990 and when I came full-time was actually working in a nonprofit mathematics teaching organization using Socratic methodology to teach algebra, calculus, and number theory to 4th, 5th, and 6th graders in Dallas public schools. So I have kind of a varied background. And from that, I taught at UTA during my summers while I was in the nonprofit program. So I've been associated with UTA and teaching at UTA on and off since 1990 and full-time since 2001. And I've been assistant dean since 2007, I guess. So my official title is I am professor of instruction in computer science engineering, and then I am assistant dean. All right, Rosie, all set. So we're going to let you introduce yourself and tell us about what you do, and then we'll get to Hyejin after that. Go ahead, Rosie.
Hi, everybody. Rosie Kallie. I am in industrial engineering, and all of my degrees are industrial engineering. I found that vein, and I've stayed in it. I'm from Michigan originally, and that's where I earned my bachelor's degree, master's degree, and then I came to Texas A&M for PhD studies. Once I graduated, had a variety of jobs, but even as a student, Michigan area, Motor City, a lot of us students did internships or co-ops or consulting there in the automotive industry. I loved working for all of the auto companies. I especially liked the test driving, the fast parts. So that was always fun out at the test track. Here in Texas, I've been more in education area. I'm actually a teaching professor in industrial engineering, so I don't have a research area, but I would call myself a teaching scholar. I have taught from infant ages all the way through graduate studies, and I do have a credential in college teaching. So teaching is my groove. I enjoy the students and the creativity and how they think, and they're techies, but I'm enjoying all of the student work. Outside of the classroom, I've worked with Dr. Tiernan with outreach, and as well as some community activities with children. So children and students are my life.
Thank you. And Dr. Moon has joined us. So if you'll introduce yourself briefly, tell us your department, tell us a little bit about your research. And you're still muted, so if you'll unmute yourself.
Okay, hi everybody. My name is Hyejin Moon, and I'm in mechanical and aerospace engineering, and I'm currently associate professor here. And my research field is field of the micro electromechanical systems. The abbreviation is MEMS. and where we build micro scale systems, which is working, create the mechanical motion using the electrical power, or the other way around. We are working with energy conversion in the different format. And such devices usually work as transducers or sensors. So in the large definition, I'm building a different type of sensors, chemical and then physical sensors. And then for my the more narrower definition of my research is build up the microfluidics, where we build a device to handle the fluid in the very, very small scale, in the nanoliter scale or picoliter scale. And then such devices will be useful for biomedical applications and the medical devices and chemical sensors and so on. So that's my research field.
Thank you so much. So we have a number of attendees with us, and attendees, you guys can see that we have some amazing women faculty here at UTA. So what we're going to do, as I said, is we have a set of questions we're going to use to sort of start discussion. But again, if you are watching, please put questions in the Q&A, because we would love to address your questions specifically as part of this discussion today. So what I'm going to start off with is I'm going to ask a question, and then I'll go around to everybody and just get your input on the question, okay? So my first question, and I really am asking this as much as anything for thinking about the students too, is how did you get into the engineering field? What was your path? So who would like to start us off? Anybody? Anybody?
For me, the answer is very simple, because since elementary school till the high school, I always fell in love with science and math. I love those subjects, especially chemistry and physics was my most favorite subject. So when I select my major before the college entrance exam, I was thinking either go to the science or engineering. Although I didn't know what engineering really is back then. So I was thinking those two pathways, and then thanks to my father, he loves the engineering better than the science. So he actually drew me to the engineering field. So for my bachelor's degree, I studied chemical engineering. Later, I changed to mechanical engineering, but they are pretty much similar to each other.
All right, thank you. I saw Sherri had unmuted, so go ahead next.
Sure. For me, it was very interesting from childhood. I was very interested in building things. So that drove me to construction, which actually you can see what you're building, if it's a building, if it's a bridge or a highway, and it stays for a very long time. So that was interesting to me. And I remember somebody, when I was very young, told me there are two things in the world that stay for a very, very long time. One is movie, and the other one is the buildings. I was not interested in the movies, so I was interested more in the buildings and highway infrastructures. That took me to the engineering and civil engineering. So I studied architectural engineering and civil engineering, so I have perspective of both sides.
Awesome. Let's see. I thought I saw somebody else on mute. Rosie, go ahead next.
Well, from a little girl, kind of similar to other people, I really liked mathematics and then the science. And I thought, hey, this is pretty fun, but I didn't know that you could actually get a job doing that. So it was interesting to find out that my love of math, science, and organizing. I was always finding a new way to do something organized. I was driving my mom crazy. But when I found out there was an engineering field that was associated with it, I said, oh, okay, I do that already. I can get a job. That's perfect.
Awesome. Haiying, go ahead.
Right, mine. I consider myself a builder. When I was young, we don't have kindergarten. We were too poor to go into kindergarten. We didn't have toys, so my childhood before school was building toys for ourselves, learn from the older kids, and that really get me into basically building everything that I can get my hands on. And so, and I got really interested to understand trying to understand how things work. And so that is basically led me through school that I really enjoy physics. Like some of you that mentioned that you are really at math. Math was not my forte, but I really like physics because I can see how, it explains how things work. And then that's how I got into engineering, is really to see the logic driven on things, how it works.
Excellent. Caroline, what about you?
So I actually wanted to go last because I was really curious as to what had brought the other four ladies into engineering. And I'm a little bit different, actually. I would not say from early childhood or even later that I was drawn to STEM or anything like that. I was kind of planning on being a music major. I enjoyed writing, I enjoyed music, performing, and I had very practical parents, and my father had been an liberal arts major, and he worked at Caterpillar for his entire career and started at the very bottom and worked his way up. And he said, you're good at math and science, you need to consider engineering because that's what's going to get you a good job. And I said, okay. And so we did college visits. I'm originally from Illinois. And so we visited the state schools around Illinois, and I went to University of Illinois to visit. I wasn't a student there. We did a visit, and I went to visit the different departments they were putting on, describing what they did. And I think my father originally thought, oh, mechanical engineering for sure. And I went to their demo and I was like, no, that's not for me. And then I ended up visiting Bradley University, which is a small school in my hometown of Peoria, and ended up being really fortunate to talk with the chair of industrial engineering. And he was just a really great guy and described IE to me, and it clicked right away. I was like, oh, this is cool. This is the kind of thing I'm interested in. I like the people aspect. I like the organization aspect. It all kind of made sense. And, a lot of my family is in manufacturing field. And so there was kind of that connection as well. And so that's what I did from undergraduate, was industrial engineering. And then my master's and PhD are also in industrial engineering. So a little bit different from the others, but like Hyejin said, very strong influence from my father, I would say, is the primary driver.
Excellent. I get to throw mine in here too. So I liked math. I didn't particularly like science growing up. My father's an accountant and my mother is an artist. Nobody in my family has any technical background. And so I was growing up assuming I'd be an accountant. That's what you do with math, right? And my calculus teacher in my senior year of high school taught a class called computer math. At the time, because I'm old, there was one computer shared by all the high schools for this. Each high school had this class, and one computer was shared, and we literally had to drive from our campus to the other campus where the computer was once a week. We used punch cards, you typed everything out. But I fell in love with the logic of writing programs. And I tell my kids today, what we were writing programs in zeros and ones and typing them out on punch cards, and they're kind of like, you're nuts. But the logic of being able to use the computer as a tool to solve problems, I just found that fascinating. And that's how I ended up choosing computer science in college, because of that one class in high school that introduced me to it. I actually graduated undergrad and had no intention of getting more degrees. I had no intention of teaching. I went to work at Texas Instruments as a software design engineer and ended up volunteering in the teaching program that I mentioned because TI supported that program when I started. And I actually started teaching. I would teach in the morning, like 1 hour, and then go to work. And TI would treat that hour like I was working. That was their contribution to this project. I started a master's degree because I was bored. Because work was, school had been, you have to take all this time and do homework. And work was like you go to work and you're finished with work and you go home, right? You can't take work home with you from what I was doing. It was government stuff. So I had all this free time. So I started taking classes. I started a PhD because I met someone who was consulting on a project at TI, and she was a faculty member here at UTA. And she talked me into becoming a PhD student. And after I got my PhD, I ended up going back to the program I'd volunteered for and teaching in that program for 7 years. And when that program closed, that's when I ended up coming to academia. So I've always thought, as I think about my career path, how different what I'm doing now is what I had no conception of doing anything like that. Even when I was an undergraduate, I had no conception of ever being a faculty member when I was an undergraduate. And of course, I was a computer scientist, so I was especially nerdy and not able to communicate with people. And, you know, I've learned all of that over my career as well. But like I said, my dad was an accountant, and he had a wonderful workshop in the back, and I used to do stuff in his workshop with him. So I liked to build stuff, but I really hadn't thought about engineering at all until I actually took the computer math course, and then still didn't think about academia until way down the road. So we all have such interesting different paths for how we got here. And I think students sometimes think there's, you know, a magic path to getting into it, and they don't realize how many different ways we come into it. So I just got from all of you how you got into engineering. And before I say this, attendees, remember you can ask questions. There's a Q&A, so put your questions out there. I just asked you all how you got into engineering. So my next question is why? Because we know there's not a lot of women in our fields. Now, IE's a little different. You guys are fairly parity, but why did you choose engineering? So anybody want to throw in a little bit of why? Caroline, you kind of said your, you know, family thing, but Sherri, I see you want to say something. Go for it.
Sure. So for me, besides my passion that I have for buildings, infrastructures, actually I was very good at math, better than other areas. So it was easier for me to learn about it. The other thing is the challenge, you know, around engineering, the perception that it's harder for women. So whenever I hear something is hard for me, you know, I'm attracted to do it and overcome. So I would say that challenge was interesting to me. And I went into the engineering and I really enjoyed it. I really don't know why this misconception is around it, that engineering is hard for women, by some people said, but it was very interesting to me, and that took me to engineering.
Awesome. And Rosie, I see you're ready to share something.
Yeah, the why is, it can be fun. I like what Sherri said about the challenge of people thinking you can't do it or it's too hard. My sister and I are both engineers. She's chemical, I'm industrial. I have some permission to share some of her story as well. But we came from a place, not a lot of money. Dad was staunchly against his daughters being engineering. You're not doing that math stuff. But the thing was, he was a self-taught mathematician, but it wasn't suitable for his girls. Our religious background forbade us from attending college. We just hoped they would understand. High school counselor said, blacks do not go to college. And I was like, you don't really believe that, do you? That was a different century. It's different now. Anybody can go to college. She's like, I'm not releasing your transcripts. You're not going. I said, you obviously don't know me. I am going. My sister's gone. My brother's there. I just got to find a way to get there. So I liked the challenge. The math was good. The courses were interesting. It was just getting over that initial hump to get in because there were just too many hurdles. But the challenge, as Sherri said, it can drive you. So don't let a challenge stop you. You will come across challenges regardless of your background.
Excellent. Anybody else want to share why they chose engineering? Hyejin, go ahead.
Since you asked why, my answer must be start with a because. So my answer is because I didn't know what engineering is. It sounds funny, but what happened is I'm the first child of my family, And then none of my family has any kind of the engineering background. So nobody knows what engineering is. So I just purely select my major based on my interest. So I like physics and math, so that goes to engineering. And then I love chemistry, so I chose my major as the chemical engineering. Before I took the entrance exam, that's what happened back in Korea in the 30-something years ago. So after I finished everything, passed the exam, and then I came to school, and then saw my colleagues, and then I figured out that, oh, there are not many girls. So before then, I really didn't know it's a man-oriented field. I had no idea, and then I think because of that reason, I didn't have any barrier to choose the engineering as my major, because I thought that my similar colleagues, girls, will choose the same decision, but that was not the case.
Cool. Anybody else want to add? Hyejin.
Right. Mine is because my English teacher in high school told me that girls should not study engineering, and he was my least favorite teacher. And so I just and it just happened that actually his daughter was my best friend, and he forbidden his daughter to study engineering or science. He forced her to, because at high school we have to separate into liberal arts and science and engineering. And so she was forced, my best friend was forced by her father to go to liberal arts. So we were in different classes. And so, he said on my face, say, girls should not study engineering. And I just look at him and say, I will show you. So at that time, actually, I was considering either going into journalist or do some engineering or science related. And so he made the decision for me.
Cool. All right. Anything you want to add, Carolyn?
I guess I would say, I mean, I kind of said why engineering, but maybe I can say a little bit just briefly about why I stayed with it. Because I think now I know quite a number of students do start their undergraduate program in engineering because their parents say, you should be an engineer, you're going to make good money. And it doesn't work out that great for everybody because it's not a good fit for everybody. But it did work out for me, and it was because a lot of it was because of really supportive faculty who'd taken interest in me, and just, I enjoyed the courses, especially in computer simulation and programming, and just the more I learned about it, the more I realized, oh yeah, this is actually something I enjoy. So yeah, it was kind of a gradual evolution, but especially as I got to the upper level classes in IE and did the simulation stuff, and I realized, oh yeah, I really enjoy this. I'm good at it. And I did feel like there was the opportunity. I mean, it sounds a little cheesy, but like to have an impact in the world. To have a positive impact on systems. Engineering kind of lends itself to that, I felt like. So that's why I stuck with it.
Cool. Thank you. So here's one that a lot of people don't ask us. What do you like best and what do you like least about the field of engineering? So I'm not necessarily talking about your job, although it can be related to that, but overall, in what you've done in your career, what do you like the best and what do you like the least about what you've done? And I'll start off just by saying that one of the things I like the least is expectations that other people put on you. You guys mentioned it, somebody says you can't do something and it encourages you to do it. So expectations that because I'm female, I can't do computer science. Because of my first name, Carter, which I started using in college, I remember going to interviews on campus And the interviewer, when I walk in the room, they're looking around for Carter, the guy, you know? And when they realize it's me, you can physically see them shift and go, oh my gosh, I'm going to be talking to a woman, you know? Granted, this is a little while back, but still, it's a big deal. And we know that there's still discrimination out there. But one of the things I love best is problem solving and being able to use the computer to do so many amazing things. All right, Sherri, you had your mic ready to go. What do you like best and what do you like least?
Sure. So the best that I like is the recent advancements that we had in engineering and integration of social science into engineering. So it's not only based on the math, but we are making decisions actually seeing humans, what is their needs. And it's very interesting to have a diverse perspective, which did not exist, I would say, 20 years ago, perhaps. What I like the least is sometimes some of our projects, some of our areas maybe requires less communication some days and maybe a little isolating, but I think that can be overcome by the culture that we have and how we organize the task and how we also supervise the students that we have so they don't feel that they are isolated, they have less communication. And diversity is also very important that I would say, so different people, women, or different ethnicity, different ages, everybody can help. So be a multi-aspect and multi-criteria area, or it will be a comprehensive area for everybody. That's what I like. I think you're on mute.
I am. I usually don't, but there was like the Arlington bells were going off and I was trying to turn that off. Anybody else want to share least or best? I see Hyejin's unmuted. Do you want to share something?
Right. I think the best, at least in US, is that when you say you're an engineer, especially an aerospace engineer, you get respect right away. So especially for a petite woman, Asian woman like me, lots of times people don't take me seriously. But once they learn that I'm an aerospace engineer with a PhD, and you can see the attitude change very quickly. The least things I like engineering, it might have something to do with where you live and work, because most engineering jobs, especially for PhD, are limited to big cities. So you may not be able to say if you want to live in your hometown, and maybe the job opportunity might be limited.
Okay. All right. Anybody else want to share? I won't make everybody speak unless you want to. So, Hyejin, go ahead.
Yeah, so my answer is probably very general, but the best thing about engineering is what you come from your science, like theories, equations, and those mathematical expressions. Now you are applying those knowledge into the real system, and then your output of that application is real values, and then real building of the systems, real device, real measurement of something. So we are dealing with the real world problem. That's, I think, the best part of the engineering. But the least fun thing about engineering is also related to that fact that we are dealing with the real world. Real world include people and money and society and politics. And so the theoretically best solution is not always the best solution under the given circumstances. And the engineering has to dealing with the the circumstances as well. So I think that's the least fun part.
All right. All right. So let's see. Okay, I think everybody's spoken who wants to speak. And we have a question. Yay! So one of our audience members, who is a freshman, is asking, what advice do you have for freshman women who are just starting in engineering or computer science majors? So think back, think currently. What would you like to share with our freshmen as they're starting their careers? All right, Rosie, get us started.
Okay, yeah, thinking back, young freshmen, getting with study groups, someone, sophomores, juniors, seniors, hanging around them when they're studying, 'cause they're going to find a lot of fun, but listening in on the conversations they'll probably talk to you about study tips, how to manage your time, because that's one that can get away from you, not waiting for the feeling to hit. I just don't feel like it, and I'll just do this later. The ones that I hung around in the student groups for the study groups, they kept me on track. Rosie, you can't wait for the feeling. When are you going to study? Meet us at the library, meet us, you're going to do a group meet, a Discord, be on it, do your work, don't get behind. I was like, take good notes, don't get behind. I think that's what I heard the most. Don't get behind. Watch your time, managing your time.
Thank you.
Honest for the weekends.
What other advice for our freshmen would you all like to share?
Right, I would like to echo that because engineering is very logical and it's built on, every year it's built on. So if you miss the first year, some people may say, hey, this is first time I'm out of my house, my parents' sight, and I'm going to having fun. And you will feel that, once you get to the second year, you will be completely lost. So definitely build a good foundation and then get into some organization that you feel interested in and then get involved. I think that's the best way to make friends and also to start building the network that will help you in the future.
Thank you. Caroline, I saw you wanted to say something.
I think Rosie and Haiying, I would second all of that. Yeah, especially, getting a group of people to study with and to support yourself through the hard times. Seriously, having that emotional support too, in addition to the, spurring you on to get your work done. But I would also say, just a couple of things is just realizing as a freshman that you may be taking a lot of the general education requirements. You may be taking calculus, chemistry, that might not be your thing. It might be really hard, might not be, but just to realize that as you move forward in your degree program, you're going to most likely get to a lot more interesting and fun things. So, getting those fundamentals out of the way, as Haiying said, and making sure you understand them and learn them properly, but also realizing that, there's more after that. And then I would also say it's probably, it's a little harder probably to get an internship, when you're a freshman, rather than as you become an upperclassman. But if you can get some kind of experience, internship, or possibly an undergraduate research experience with one of the faculty here at UTA, get some kind of little bit of experience in your field so that you can kind of get a feel for what is this actually like to do this after college. Because I think it's really important. You may find, oh yeah, this is really cool and I want to do more of this, and it'll help you kind of, inspire you throughout your degree program. Or, I mean, not to be negative, but you might find out like, whoa, this isn't exactly what I thought it was. And that might, make you think, okay, maybe a different field of engineering would appeal, or maybe a different field altogether might appeal. So trying to, as much as you can, even if it's unpaid, but trying to get some practical experience in your field as early as you can is really great.
Very good. All right. So I know the audience can't always see this, but I can see everybody's faces while they're speaking, and there's lots of nodding going on in the background, agreeing with what was being said. The other thing I would just add for freshmen, and it ties into what was already said, but remember that the first year is the foundation. Sometimes you go, well, I'm not automatically, building things, right? As a civil engineer, I'm not immediately, looking at how power works in mechanical systems. So this isn't mechanical engineering, this isn't civil or whatever. Remember that you've got to build the foundation so the rest of it makes sense. And so even if it doesn't feel like you're applying it or you're not really doing whatever it is, especially things like calculus, maybe, right? Computer scientists are always like, why am I doing physics? I don't need physics. And what I said was, look, we have a current CS student who's worked in Lawrence Livermore Laboratory for the summer because he worked with physics professors that doing their computing stuff. You don't know where this is going to tie in. And like Carolyn said, you may find out you don't like something. You can look at your field of engineering and say, I could apply it in this field, or that part, or that part, or that part. And you may get an internship in piece area over here and decide, no, that's not the area I want to go into. There's still lots of other choices. So finding out what you don't like is just as important. All right, so we have yet another question from the audience. Yay, questions from the audience. So this one is broadening out from just engineering, but what's your best work-life balance tip? So thinking about what you do now or have done in the past and your life outside of work, what are your best work-life balance tips? Sherri, start us off.
Sure. So one thing that I suggest is to be efficient and more efficient. That's what I learned. So waste of time should be minimized. So when I'm in my office, either I work. If I'm not in a mood of working, I don't deceive myself. I just leave. Okay, some days I can work 10 hours, 12 hours, some days maybe less. But I learned that we all should have some time for ourselves every day, a small time. If it's for our exercise, if it's for mental health or anything, your relationship with family, if spending time for your kids or your husband or anything. So make sure that you have a great balance. You don't sacrifice, do not postpone something to next year. Maybe after I get my degree, after I get my dream job, after I get my tenure. That's what I learned. Time passes and that best time, perfect time never comes. You have to create that time and you have to prioritize things. So I learned what is important, what is urgent, and then prioritize them. And based on that, select some that I can do a day, and do not punish yourself if you are not on a schedule. We all have some long list of overdue things. Just try to be efficient and on a schedule and track your day and plan the day before for next day. I think that would help you a lot. So that's what I learned throughout my career as a student, as a faculty, and it helped me a lot.
And Rosie's waiting unmuted.
I'm laughing and I'm echoing. Thank you, Sherri. I think a lot of that is, I would agree 200%. You do have to, one of the highest priorities is taking care of yourself, because if you're empty, you can't do the schoolwork or anything else in your work-life balance. So if you're not getting your water every day, you're not resting, you're half eating, you don't exercise, so your mood is ditched, no vitamins. On technology, a whole lot, and it's frazzling you. So the rest of the balance is going to be poor. You got to take care of yourself first. You know, the prioritize when you're going to eat. I'm going to take an extra lap walking from Coba to Pickard and just squeeze all those things in. As Sherri said, prioritizing even as a student. Yeah, they're going to go watch this movie, but I'm going to study for an hour and I got to do my walk, and then I got to meditate. I mean, so some things, good versus great, you're going to have to decide and make sure that you're up there with the great things, that you're not at the bottom.
Okay. Anybody else? Haiying, go ahead.
Right, I will say don't equivalent work to hours, because lots of students say I'm working 15 hours per day and I'm still not doing well on grades. I said that's the reason you are not doing well in classes, because you work 15 hours per day. Right? You have to know yourself and then know when is your most efficient way of working and how much sleep you need. Do you need at least an hour in the gym? So look at those things, and a lot of things go back to efficiency. Is a lot of things, if you do it right and follow the logic, you can do a lot more within the limited time you have. So I always tell my students that if you are doing something over and over and over again, that means you are not doing it right. So look at the things that you are spending lots of time and that doesn't go anywhere, and that means there is a better way. And I would say a good engineer is a lazy engineer. so that, it's engineering is not to put how many hours in it, it's how fast you can get the results. Look at how you deal with things and then decide the most efficient way to tackle the problem.
Excellent. Okay. Anything anybody else wants to add? I've got more questions coming up. Rosie, you have another comment?
I did, just real quick. I think I mentioned it before, but I want to mention it again. Follow the logic. As Hyejin said, don't follow the feeling. Evaluate it by the feelings later, but follow the logic and your schedule first.
Yes. All right, so now we have 3 questions, which is cool. So the first question, or the next question, is age a factor when entering the engineering field? That's not one I think about much, because I think some of us, we all kind of got into it around college age. So what do you think? Is age going to be a factor?
I can say age itself is not a factor, but with different ages, you have different responsibilities and different time that is available. So maybe when you're younger, you don't have much financial responsibility. Your parents are supporting you. But when you are, later in your life, you have a family, you have kids that you need to support. But again, none of these things should stop you. If it's your passion, if there is a will, there is a way. That's what I believe in it. So never be discouraged. It's just a different path that you have. I had classes that I had women in 50s, believe it or not, that I was in Morgan State University. Most people were working before here, and they were finding a way to do it. So don't compare yourself. Don't be discouraged that why I didn't start earlier. Actually, you should be proud of yourself that you start later and you have the drive and you're persistent and follow your dream. So younger or older, we all have advantages and disadvantages. We have to see that what we can take advantage and move forward toward our passion.
Nice. I would also say one of the, for some people coming into it in college is maybe too early. Some people are not really at the level of maturity for them to make the decisions and have the balance and some of these other things we've been talking about. And maybe for them, it makes sense to either wait for college, do something else first, and then develop into where they're ready to be an engineer. So I think there can definitely be a benefit if you're coming into it at a little bit later age. I think I think we're lucky in some ways at this point because the field is much more open to diversity of all different kinds, including age diversity. So I think that's a good sign. Any other quick questions on, or quick comments on age before I move to the next question? All right, Sherri covered that succinctly. Wait a minute, Haiying, go ahead.
Right, so I don't know the person who asked the question whether she's in 50 or 30, how old is old, right?
Right.
One thing I realize is as I get older, my memory definitely deteriorated compared to when I was a teenager, that I can almost have photocopy memory, like I can read a chapter and almost recite 90% of it, but now I couldn't even remember a paragraph. But the benefit of engineering is so logical that you actually don't have to memorize a lot of things. Like for me, like all I needed to know is Newton's law, and I can derive everything from Newton's law. So that is the advantage in a way to working in a very logical field, because you don't have to do a lot of memorization.
Yeah, I was always lucky that way because my memory is terrible. It's always been terrible though, so. All right, so I'm going to jump to the next question. And this is, we may have all experienced this, but you may have students who this feels. The question is, what would your advice be for someone who feels stuck while in their engineering PhD program. So we have somebody, they're at a point and they're stuck. What do you suggest?
I found that when I was stuck in my PhD program, I not only talked to my PhD advisor and say, I'm feeling stuck with the research or just mental block. I also talked to my mentor who was outside of the department. So someone with eyes, not focused so much on the technical, but as the whole person, to give me some ideas of ways to get unstuck mentally, unstuck physically, other ideas, just to kind of get a good balance so I could evaluate where I was. Because part of it, I couldn't even see clearly my own situation. So going to someone else to help me sort that out and give me some pointers, and actually sent me to take a little class, and it helped me get going. But on my own, I couldn't see it. I needed to reach out to somebody.
Sherri, you want to go ahead?
Yes, actually, I would say most of us, if not all, we got stuck at some point during PhD. That's the nature of research. You're learning how to do research in PhD, and it's different when you do undergraduate or master's because you can see the progress. One semester is completed, this number of courses are completed, but with PhD and research, you don't actually see it in the same consistent pattern. Maybe after 1 year, you don't have any progress, and then within half a month, you have a lot of progress. You're trying different modeling, for example, techniques, they don't respond. So it happens for you. You need to be patient. It's not just you. Just understand that. Don't put pressure on yourself. Just continue what you're doing. And if you are doing it correctly, you have a great supervisor, other committee members that they're guiding you, you will move forward and reach the end point. So it's not just you. Remember that.
Hyejin, go ahead.
Yeah, as Sherri said, all of us probably had experienced the stucking somewhere in our lifetime, and especially PhD, the years. We will experience a lot of failure, and then it makes you actually feel down, and then you feel yourself you are not capable of doing this, and make you feeling like I don't want to do it anymore. I don't want to do something else. All kind of feelings maybe come up from your deep in your side. But when I always share with my students that without the failure, you cannot be a good researcher. So research is a series of the fail and then modify or a revisit of your problem, and then find some differences, apply it, fail again, do it again, fail again. That's the learning cycle, and then that's how the researchers make a progress. So just the failure of your whatever you are doing, that little things, that's not the failure of your entire research career or your life. So you just embrace your failure, and then try to figure out, try to learn from your failure that make you make a progress. That's the one thing. And the second thing is, nevertheless, when you stuck into some point and then feel like you are circling in the same path over and over and over, that make you really down. And in such situation, my advice is, do whatever you can do. Doesn't matter, no matter how small it is, just try to do. Doing is very important. Sitting is so easy, but sitting doesn't solve any problem. So doing is the solution of getting out of the circle. So for example, just reading a textbook, revisiting your old knowledge, that's something you can do it. Going and the exercise, cooking and then feeding yourself is a better food, and talking to your professor or anything, whatever you can do. Doing is the important part of the, getting out of the circle. That's my advice.
Excellent. Okay. Carolyn, go ahead.
I did want to add to what a number of people have said, but especially Rosie, that because I can think of a point specifically in my PhD where I did feel stuck. And for me, the one thing that did it, I just decided to make some changes, and the big one was connecting socially. And so I'd been a little bit isolated, been mostly working at home because it's quiet at home and that's a good place to focus. I was kind of disconnected from the other PhD students. And so I just decided I'm working on campus in the lab pretty much every day. And I just started doing that. And if things got too chatty in there, I'd go over to the library. But just being around people, being around my peers, building up relationships, being able to take a break and go to lunch with somebody and just, vent, basically, to having that network around you. And then as I got a little bit further in my PhD, I went to conferences, and that was kind of another thing that helped me kind of broaden my perspective and meet new people and help me learn, where I'd been stuck in some areas, give me brand new ideas about, oh, I could try this. So for me, the social aspect was really, really important. And I would add that kind of ties into the work-life balance thing too, is making sure that you're not just, hiding out in your office all the time, grinding away. I think it benefits you personally, of course, and health-wise, but also professionally to get out and be social.
Excellent. And us introverts have to work harder at that, but it's still valuable. I would also add, remember, persistence is part of what this is all about too. So being persistent and, like Hyejin said, really acting, trying a new thing, And if you do get stuck, I know that I have a tendency to turn in. So like Carolyn said, turn outward, ask questions, and don't forget to talk to your faculty member. That's really important. And I liked what was said about having a mentor who's beside your faculty member. And maybe right now you don't feel like you have that mentor, but I will offer myself, and the other faculty here might offer it. I will offer myself as anybody's mentor outside of their research. You just want to talk to somebody else who's done a PhD that has nothing to do with your lab, feel free to get in touch with me. I would be more than happy to be a sounding board and just, help you get a different perspective, because sometimes that's enough to really help you move. So you're welcome. I'm Dr. Tiernan at uta.edu. Very simple. I'll put it in the chat. But don't turn inward too much. Remember to keep connecting. Okay. All right. So that was excellent advice for our PhD question. Another question. Any advice for an international graduate student to fit in and adapt to a new situation more easily? So I know some of us here are international and some of us are not, but I think we all have certainly experiences with our colleagues and our students. So where would you start? Advice for an international grad student to fit in and adapt to a new situation more easily.
I would say the best advice I got when I was an international student come to a new country is that a gentleman said, make some friends, not from your own country. Especially, we have a tendency, and it's feeling comfortable, we speak the same language, have the same experience. So lots of international students tend to kind of band together, which is understandable. But it helps to have a friend that know the local culture, so to speak, and then you will learn from that. So don't limit it to your small circle, go out.
Excellent. Other advice anybody wants to share? Okay. All right. So, Hyejin, you want to add something?
Yeah, sure. It's basically the same thing. As an international student, breaking a barrier of your own culture is very important part in the beginning. So make a friend with the diverse background is the best way to mingle and then break your, own culture and then learn different cultures from others. So, and then graduate student, you will always have a stress from your class and research. So best way is, making a study group with different background people. That's what I did when I was a graduate student. I organized the study group with people from the different country, and then we studied together. So naturally, within while we were studying, we learn each other different cultures. We talk about, of course, I learned the English and so on. So why don't you organize your own study group?
There you go. Be active. All right, so I noticed that we are actually out of time. This went so well. Thank you all so much for participating. If you're observing in the chat, my email's in there. Dr. Kallie's email is in there. Again, if you're stuck, you just want a sounding board, feel free to contact us. We would be more than happy for you to just, have some other ear to share. We are very appreciative that students, you joined us today. Faculty members, thank you so much for taking this time to share with our students. And everybody, know that we have lots more virtual brown bag sessions for the rest of the semester. Check out the schedule, and we look forward to seeing you at another event. Thank you all so much. Have a great afternoon.